Today we're going to review how to simplify expressions. The first thing to understand is what a like term is. Like terms are terms that have the same variable raised to the same power. So for example, I might have 8x and 4x are like terms. I could have 3xy squared and 10xy squared. These are like terms because what I have for variables match up exactly. In this case, I have both x's. In the case of 3xy squared, I'm dealing with xy squared, xy squared. The number in front is what's called the coefficient. In a sense, you can think about the coefficient as being how many of that particular variable do I have. So for example, here I would have 8x's and 4x's. Here I would have 3xy squareds and 10xy squareds. Now 8x and 4, for example, would not be like terms because the 8 has an x with it, it's 8x's, where the 4 is just by itself. Similarly, if it was 8x squared y and 4xy, these would not be like terms because what I have here and here do not match up exactly because of the square term. So what happens when I go to simple expressions? So let's say I gave you 8x minus 3 plus 2x minus x plus 5. The important thing is to pull together what are the like terms. Keep in mind that the subtraction is like adding then a negative 3. This is like adding a negative x. In this case, whenever there's not a coefficient written, it's understood to be one of that particular item. So I'm going to go through and kind of circle. Let's kind of collect what are all the like terms. So here I would have 8x plus 2x plus a negative 1x from the minus x. In order to add these together, 8 plus 2, and then I subtract 1, 8x. So in a sense what I'm doing is the reverse of what's called the distributive property, which we're going to touch on in the next slide. So it's like I have 8x's, 2x's, and then I need to give away an x. So 8 plus 2 is 10, minus 1 is 9. So I have 9x's. And then for other terms, I've got a negative 3, keeping in mind the subtraction sign follows the number after it, plus 5. So negative 3 plus 5 would be plus 2, which would be my answer. Okay. The distributive property basically is the fact that when I have a number in front followed by numbers inside or variables inside, I have to take this number in front and I need to distribute it to both terms. So in this case it becomes 3x minus 3 times 2, which is 6. Okay. One thing just to be aware of with the distributive property is if I do something like 1 minus 3 times x minus 2, for example, this 3 is really negative, so it becomes the 1 plus, if I distribute this, it's negative 3x, and then distribute it here, I've got two negative signs, so it becomes plus 6. So I'm left then with negative 3x plus 7. The 7 comes from the plus 6 and the 1 in front. Another way of thinking about this is 1 minus 3 times x minus 2. It's thinking 1 minus, if I distribute the 3, I get 3x minus 6. But because I have this sign here, it needs to change this sign and this sign. So this becomes negative, that becomes positive. So I have 1 minus 3x plus 6. Okay, the reason being is a negative times a negative will always be a positive. And then collecting like terms, keeping in mind the subtraction goes with the number that follows it, I get negative 3x plus 7 for an answer. Sometimes with the property, we're going to kind of use it in reverse as well. That if I gave you something like 14x minus 12, I want to look at these numbers 4 and 12 and say, what's the greatest common factor? What is the largest number both could be divided by? So for example, 12 is divisible by 2, by 3, by 4, by 6, and by 12. 14 is divisible by 2. I'm sorry, I'm also leaving out 1, which is, they're all divisible by 1, 2, 7, and 14. In this case, 2 is the largest number that they have in common. So if I pull a 2 out in front, 14 divided by 2 is 7x. 12 divided by 2 is 6. So this would be the reverse of the distributive property, where normally I'm going in this direction, taking it in the what's called the factored form, and expanding it. In the situations like I just said, where I give you start off with the 14x minus 12, I might want to go in this direction and do something called factoring it, which all goes about finding your GCF. What is the largest number they both have in common? So we'll be working some with this the next couple days.